Hello and welcome to Ellensburg Amplifier Repair and Service. My name's Todd, and today we're going to be going over the Maxxsonics Brutus BXX3000.1D amplifier. This is a customer board that came in stating that he has a protection light on and that the output terminals touched while the amplifier was in operation. So I thought I'd just go over this board with you guys here, and just a brief rundown of the amplifier. They are still using the same 064 power supply transistors. They are just one of the most common power supply transistors you'll find used in amplifiers. So this is pretty standard and typical layout for the Maxxsonics line of amplifiers. They're still using the USCon capacitors on their boards. I don't know why, but they are. I noticed though they have changed their output transistors. Instead of using the 640Ns, which they have used for a long time in their outputs, they have changed to the 40N20s on this board, which may have benefited the board for sure. Because usually when I get these Maxxsonics in, the first thing is I got to go out and cut out a bunch of shorted output transistors, especially when you short out the output. But amazingly, there are no shorts on these 40N20s. No shorts on the power supply, no shorts on the 40N20s. So it may have been a very good positive move for Maxxsonics to switch to the 40N20s, because it really does probably save them a lot of money in returns, because these did survive, I do believe. I'm not showing any abnormalities here. I am showing good diode junctions. Yep, I know, I said it, using diode junction. Resistance came out good on this, so I was like, that's odd. So I switched to diode. So I switched to diode function, and I do have good diode junctions between the gate and source and drain and source on this bank here. However, I don't have good diode junction readings on this bank. Now, I don't think it's the readings of the transistors themselves. I think it's the readings of this drive card, because this is showing all over the place. And you'll see right here on the scope that something odd happens when we go to power up this board. So this is just my 12 volt 2 amp power supply. Just the normal everyday testing that I do here, and I'm just going to pulse this real quick, and I'm going to go over here on the rectifiers real quick and just watch that scope. You see how that scope is climbing up on the rectifier? Well, and here's the power supply. Nothing, of course, right? Nothing. I do get a red light coming on, but I'm getting 12 volts creeping on the rectifiers. So that's telling you, you got to work backwards. You got to go back to the rail here. So if you come over to your output section, if you come across these 40N20s, there it is. Gate, drain, source. And that's going to be for both banks on each side of this output. And this, right off the bat, should point you right to this drive card. So I'm going to bet money if I remove this drive card here that I will get some drive signal over here at the power supply. Because remember, on these boards you have a few protection circuits. Well, this board here has your protection circuit that watches your overcurrent, which is this top IC right here, is labeled as U5 on this board. And over here you have 5 resistors. That is your resistor network that works in conjunction with your shunt resistors. So this right here is responsible for your overcurrent protection. And I'm sorry, it's a little hard to see on the camera what I'm pointing to, but when I get this board out, I'll show you. So that's typically why I have the customer leave a brief description of what is going on and what they think may have occurred to cause that. And a shorted output will point me right to the overcurrent protection circuit. Because this board here, if it senses any issues, will send a signal right back to your power supply drive card. And if you were to take readings of the power supply drive card, yep, you're correct. This thing is going right into protection. But it's going into protection coming from the output drive card. So you can see it real quick on the scope there. It'll shoot up if my scope will catch it. Kind of hard to see that on the software, but this pin in the IC goes up and goes up to 12 and shoots right back down to 0. So that says, telling the power supply, nope, not time to turn on, there's an issue. So what I'm going to do is I'm going to fire up the Hacko here, and I'm going to remove this drive card and see if our power supply will come to life. It'll still power up. It's just not going to give us any output drive signal because I'm going to have the card removed. But it will power up. It should power up with a green light with this card removed. So I'll be right back with you. All right, I am back with you on this amplifier board here. So I pulled the output card on this and went to pulse the power supply, and I still noticed that I was like, oh, what's going on? I was still getting 12 volts on the output terminals of the speakers, and I just couldn't figure it out. I was like, what's going on? And what's another rule for a Hiphonics board? There's a few rules that pertain to these boards. Is anytime you have a shorted output, not only do you have to worry about this IC right here at the top, but you also have to check it's called R ground and C ground. This is the bond between the primary and secondary of the amplifier. And before they used to use a resistor and a capacitor, but lately I've noticed they've just been using jumper, 0805 jumpers. And sure enough, when I was reviewing the board, I was like, where was this voltage coming from? I found that both of those jumpers were they were burnt wide open, completely open. So now I have installed new 0805 jumper, 0 ohm jumpers there on R ground and C ground. So now I'm reading a good 0 ohm junction between that secondary circuit there. So now when I power the board up, I do get that pulse, because it's a 2 amp supply, so it kicks it out just for a little bit as the rail voltage starts to build. So here's the rectifier. So we're just going to slowly pulse this rectifier, the power supply, on up to its running voltage. So we're at 40 volts now, 50 volts, and it should fire up this time. There it is, 75, 76 volts, and the relay clicks in. So, and now I have nothing on the output. So then you got to ask yourself, all right, so all the 40 and 20s are good. I did have a failed R ground, C ground here, over here at the power supply drive circuit. That's typically where you'll find those. But the question is, did this make it? Did this survive? Now, you have to be real careful with this. what I'll do is I will let my rail voltage discharge, because unlike other boards, audio pipe, they have rail discharge resistors installed, so it will discharge the rails slowly. Again, you don't want to get yourself crossed up in the rail voltage. This is about 80 volts DC with a pretty good capacitance, so you don't want to get your fingers across that. Trust me, it doesn't feel good. So it's dropping slowly. We're down to about 24 volts here. We're good enough to just temporarily slide the card into its pins, and what I do is I tip the card to make good contacts with the vias. So I'll slide the card back into the pins and see if I have room to tip this card back to see if I can get a good drive on this. It'll go right into protection if I don't get a good drive. So, and what we'll do is, just like any other amplifier, you should see a negative rail drive and a rail-to-rail drive if these 21844s survived, which I'm probably guessing they did. All right, welcome back. I'm not sure where I left off. Something happened to the laptop where the battery pack decided to shut the laptop down. So where did I leave off? All right, so I was testing the drive circuit with the drive card not started in place, and that's where I ended, I do believe. So so I got the drive card. It is soldered in place. Let's go ahead and fire up this power supply. And just to let you know, there were two shorted 40N20s on this board. And these 40N20s are a transistor that Mauser doesn't have. They're just not really readily available. I just quickly searched. My go-to is Mauser. I haven't checked LCSC or my overseas supplier for the 40N20s. And I don't have 40N20s on hand because I am not used to seeing this in Maxxsonics boards. It makes sense. I'm glad they went with the 40N20. It is a higher current rated transistor versus the 640s that they've used forever. But again, I didn't have any on hand. So what do I have here? I have the IRFB 4127s installed. So if you're to look at the data sheet between the 41 and the 4127 versus the 40N20, you'll see that the current rating on these are substantially higher. So these are rated at a much higher current. And they're very comparable when it comes to specifications, I should say, on the characteristics of how they run and how they function. They do have a little bit higher capacitance. It is using a 22 ohm gate resistor, original on the board here. So what I'm going to do is I'm just going to fire up the power supply here. And let it do its cycling here as it builds the rail voltage. I do have a 50 hertz input signal here. All the gains are fully counterclockwise, as usual. And let's see. So there's the relays clicking in. So we do have the relays, and here's our low side drive. Of course, it's modulating because I have a 50 hertz input signal. There's our low side, and then you're going to have your your rail to rail. Of course, again, it's modulating, so you'll see it's not really clean on the left and right hand side of those signals that you see, because it is modulating. So, which is good. That's a good sign that's modulating. So let's check our output here. Sorry as I reach across to the scope. So our output signal is, of course, a nice good 50 hertz there for you. So the 4127s are just a excellent sub for the 40 and 20. Of course, I will do full load testing on it, but I'm not feeling any heat from the gates on these. If they're being driven hard, driven not hard enough, not pulling down fast enough. So let's go ahead and remove the 50 hertz signal to get rid of the modulation. And let's just check out the gate drive as it stands with no signal. So let's go down here to our gate drive and just see. So you can see it looks like a pretty standard negative rail drive there. There's no overshoot or undershoot or ringing at the gate on either side. Either side looks comparable. And then the rail to rail side here, let me change my voltage here. Again, a nice good straight up, nice good straight down, no ringing, no undershoot, no overshoot. So that was at the gate, and so here's at the source. Nice good clean square output there for you. So I think these transistors will be good. They are a higher current rated, no heat whatsoever. They are higher current again. That doesn't mean you can crank it up and turn it up, because you're going to be limited by your power supply. So sure, I think it's probably going to be upwards of double the rated current of the 40 and 20. But as long as you run it like a normal amplifier and you don't run it into massive clipping or under voltage situations, it should hold up pretty strong. So that's what I have done for this board. Again, I don't have the 40 and 20s on hand, and I can't readily get them, and I'm sure the customer doesn't want to wait the 3 to 5 weeks for me to get them in from overseas. So I will email the owner of this board, let him know what I have done, and if he wants me to bring in the 40 and 20s, I will. It will take several weeks, but otherwise he could go with these higher current transistors. This is not a modification to increase power. Just letting everyone know. I just had to use what I had on hand here. I do have quite a few of the 4127s, the 44227s. I do have a good supply of transistors, just not the 40 N20s. Go figure. I have the 31 N20s, but not the 40 N20s. So that's where I have left this board here. The drive card is good to go. It survived the shorted output. So really all that happened was two 40 and 20 transistors here shorted. The resistor and capacitor locations over here at the power supply for the primary secondary bonding, I guess is what they would call it, was open from the shorted output. So not much damage occurred to this board, which is great to see. I usually see a lot worse damage than this. The IRS 2 and 844s, they survived again, surprisingly well. They must have changed some designs, which I noticed they have a lot bigger heat sink on the ICs on this card versus other cards in the past. But otherwise, good solid board. So I'll get this back in the heatsink. We'll get it on the load bench here. I have new windows going in here in just a couple days, so I got to get these boards on the load bench because the load bench happens to be right in front of a big 8-foot window. So I got to get this on the load bench. We'll get it tested here and email the owner, let him know what I've done and how he would like to proceed, and we'll go from there. Again, I do thank you guys for watching. If you have any questions on these boards, please feel free to ask. I'm around 7 days a week for the most part when it comes to questions. And I hope to see you again on the next one. We'll catch you again. Thanks for watching.